Welcome to TXAPA Live. My name is Jim Warren. I am with the Texas Asphalt Pavement Association, and we are glad to have you guys here today. We are continuing our discussion on asphalt fundamentals, and that program continues today with Mr. Chuck Fuller. Welcome, Chuck.
Hello, Jim. How's everything?
We're doing well, and we are going to spend some time on asphalt plant operations. I'm going to throw an audible today, so if anybody has any questions, just go ahead and type them in. We'll see if we can work them in as we go. But Chuck, let's see, where are you at? There you are, my brother. Welcome. It's been a fun day here at TXAPA. A lot of stuff going on.
We've had,
but we certainly want to take the opportunity today to dive a little deeper, talk about asphalt plants, and from kind of a bigger picture.
yeah,
A
great.
bigger aspect picture. We're not going to get too deep in the weeds today, but you know, we talk all the time about fundamentals and what fundamentals mean and how fundamentals are important. And what does that mean to you?
Yeah. So, and again, it's the basics. Every time we fall into a rut or fall into a set pattern, and then all of a sudden we wake up and we say, something's going on, and we just forget about the basics. We just forget about the pure basics, and that's all we've been talking about these last couple of weeks or months now. Aggregate basics, liquid asphalt basics. And sustainability, the basics of sustainability. And now we're going to be talking about asphalt plants. And I really appreciate the fact that you're here with me doing this, because it's boring being here by myself.
Oh, come on, man.
But I do have to say that we could talk about our vest, our vest that we're wearing.
That's a nice vest you're wearing. Why are we wearing vests today?
So we have the awareness. So our Work Zone Awareness Week is this week. It's national. Absolutely. My wife, she looks at all the newspapers all over the United States, and this is National Work Zone Awareness Week. And Jim and I both are we're very adamant about safety. It's one of the most important things in our business.
Yep,
and
PPE.
Michael Lee has said one thing to me that I get out of everything that he's told me, is that if we concentrate on safety first, safety number one, and then quality second, everything else is going to fall into place. Safety first, quality second, everything else falls into place. And that's something that I definitely believe in. Again, it doesn't do us any good if we can't go home to our families, completely whole. So please be aware, people, please be aware out there in the work zone. Every day, somebody is going through a work zone, working in a work zone. We experience them every day. It's so important. Please, please, please keep an eye out. Slow down. Don't text and drive. Don't follow too closely, and observe the speed limit, and watch out for our workers. Okay, I mean, they're so important to us. So please do that. So Jim, again, we're going to talk about asphalt plants.
Yeah, let's get into it.
Again, this is the fundamentals of asphalt plants. So what we're going to talk about here is just 7 areas of the asphalt plant. We're only going to do this for 35 minutes.
Right.
But each one of these areas are so important. They're so important for that mix to come out the other end, to be able to place it, compact it, and for it to do its job, which is to last 10 years or more. And that's our objective here. Okay. So we're going to talk about,
regardless of the plant type.
Yeah, it doesn't matter the plant type. It doesn't matter where the plant's at. These are all blending, heating, drying it, doing admixtures, mixing, storing it, and then loading it. So let's get into our blending operations. So when we talk about blending, what are we talking about?
Rock.
Talking about rock.
Lots of it. Lots of different types of it.
And if you notice here, look at this aggregate stockpile here. The thing to notice here is that the stockpile are placed on paved areas.
And they're separated nicely.
I can easily drive a loader in between the two stockpiles. Sometimes if you don't have that footprint, you might want to put a separator in between the two stockpiles. Mm-hmm. And the reason we do that is why?
We want to keep the materials up. Each has a particular use. Each has a particular gradation or size, ratios. And we need those to make our job mix formula. And we don't need to blend those in the yard. We need to be able to precisely blend those in the plant.
So it's super important. When you walk out to the back of an asphalt plant, if our stockpiles are not separated, then we know we have an issue, right? Yeah. We know that we can't control that stockpile. Here we have coal feeds, and I think we have 7 coal feeds here. And again, each one of these materials are going to go into that coal feed, and they're going to go into that coal feed with a loader. So what's the most important part of the asphalt plant?
The loader.
The loader.
Because why?
The thing I want everybody to look at here is that this happens to be a very, very good loader operator. Okay, there's no material spillage in the front
Yep.
of the storage bins or behind them.
And he hasn't stacked up the material so far on the in between the bins where it would commingle and rip off from one or roll off from one side to the other.
Yeah.
Yeah.
If you notice, those bins got bin separators at the top. Those are not to overfill the bins.
Yeah, that's not bin capacity increasers. Those are separators.
Those are
to
separators
keep the material separate.
But
so.
I was real impressed with this loader operator. I can spend 10 minutes at an asphalt plant and tell you whether or not you're going to have a gradation problem just by watching the loader operator.
Yeah, how they cut into the pile, how they work the face, where they pull into the pile. You know, it determines what kind of moisture content we're getting and the consistency. You know, we talk about consistency a lot. We haven't mentioned it today, but we need to mention at least 38 times because everything we do in the front end of the asphalt plant before the material gets in there is going to create consistency on the outside.
Absolutely.
As the material leaves the plant in the truck on a job site.
So if that loader operator is loading from the backside, the front side, the side of the stockpiles, we know that it's not going to be consistent. Yep. We know that we're not going to have consistent moisture. Look at the moisture lines in those stockpiles.
Yeah, I mean, it's very visually evident. And with all the rain we got here yesterday, I imagine that line's probably a little bit higher than it is out there right now.
And if it's not on paved stockpile areas, you can not only do you got moisture, but you're going to have mud, you're going to have debris, you're going to have other things that are going to happen.
And if that bucket gets down too low and starts picking up some of that, some of those wet fines, they can end up going through the plant almost like an aggregate. And we were actually on a job looking at a project this week, and we saw some pop outs, and I'm pretty convinced it was due to
clay balls,
clay balls and just digging too low. So the paved stockpiles are nice. It shows it's good separation. Generally, when those stockpiles are made, they're also sloped.
Yep,
we're sloped so we can allow that water to give it some place to go away from the stockpiles and then drain out. Absolutely. So what's on the bottom right there?
That's a shaker deck. And the real important thing here, again, when you come to an asphalt plant, and by the way, this particular asphalt plant, no matter when you go there, it's always going to look the same.
Nice.
That they really do. So in front of the shaker deck, right there where that shaker deck is, you see how the shaker screen is sloped. Mm-hmm. If we have oversized rocks or we have clay balls, we have things that are not supposed to be in our mix, that are in our stockpile, they're going to come off of that shaker deck and they're going to be in front of that shaker deck, right?
Right.
What's in front of the shaker deck right now? Nothing.
Looks
right?
Clean.
It is clean. So these guys are paying attention to their stockpiles. They're paying attention to the loading out. They're paying attention, and they're not contaminating. If I come to an asphalt plant and that shaker deck is halfway full of big rocks, and clay balls, roots, I'm going to tell you we're going to have a problem, and that's just the way it is.
Yep.
So other aspects of blending. What else do we have? What else can we blend here?
We got 2 more bins. We got other products we can bring in. Recycled asphalt pavement, a wrap.
Yeah, wrap.
Or RAS.
And RAS. Yep. So that's the reason we have 2 separate bins, and these bins got to be separate because again, they're going to be introduced separately into the mix.
Right, and generally they're even shaped different because that material has different flow characteristics. So they're in a different location of the plant. You'll have to look around. When you look at the plant here, they're behind, and they're feeding actually behind the back house into the back part of the asphalt plant because, like you said, that material needs to go in a different place. We don't want to run it in with the aggregate and have it be exposed to very high temperatures and very high heat.
Yeah.
All we really need to do is to heat it up. So we're going to superheat the virgin aggregate,
right,
and then that's going to heat up this material as it goes into the back of the plant.
So it's real important to notice here that they have 2 separate recycle bins. One's for shingles, and one's for recycled asphalt pavement wrap.
Well, we also have fractionated wrap. So could that be two different wrap?
Could be 2 different sizes of wrap.
What do you give me the lowdown on why do we fractionate wrap?
Yeah, so fractionating the wrap is so important. We got to control our stockpile gradations, right? That's the main thing, and that's the whole reason why we have uniform stockpiles. We have uniform. When we look at our wrap stockpiles, we should treat it just like a virgin material. we should treat it as our most expensive virgin material that's out there.
Right.
Because it is. That's it. So when we fractionate it, we size it, we know the gradation, we know the moisture content, and we put it on a paved stockpile area, just like we do our virgin material, and we treat it like virgin material. And guess what? It's going to act like a virgin material. It's just going to act, really uniform. That's the whole thing, consistent. We want consistent material feed.
Right.
And again, look at the front of this bin. You don't see overpiling. You don't see debris everywhere. Again, this loader operator is super clean, super good.
Yep.
So
looks good.
All right. Our next section is heat.
Yep.
So we talked about blending. So heat is so important on an asphalt plant. And I took these pictures the other day, and it just look at the temperature difference that we have with this outer drum. We have up there on the left-hand side, 285. It goes to 346 down at the bottom section to 221. You know exactly where the asphalt's coming in at. So we have this.
And these are external drum temperatures, not internal mixed temperatures. Your internal temperatures, obviously, you're going to be much warmer. A lot of these drums are insulated, so Chuck's got the FLIR gun. He's going crazy out there at the asphalt plant, running around taking pictures and stuff. You did wear your vest, didn't you?
I did, absolutely,
right,
and hard hat and safety boots.
All right, awesome. Yeah. And but that plant is doing that mix. That drum is doing several things. One, it's blending, mixing all those aggregates together. It's drying the aggregate. Okay, it's drying that virgin material.
Yeah.
And then it's going to heat it up. And those are actually your two different operations through the process. So we've got to dry that material before we can heat it up. And we talk about consistency, and this is one of those areas that's absolutely critical to understand. Plants are designed or rated around a certain moisture removal content, and when that changes, we need to adjust the plant. And if they run a moisture content on the aggregate, they can adjust the plant as it's running. But it's been raining here in Buda for a couple of days, and I imagine it's not an average of 5% anymore.
No.
In these stockpiles, and kind of just a key thing here is that moisture content of the aggregate going into the drum has to be known, because that's how the plant is run, and they assume whatever moisture content is, and that is taken out, and we're assuming dry material coming out the back end, and that's what we use to place our asphalt content or binder in. And if we have our asphalt content off, guess what? The binder content's going to be off as well. So
absolutely.
The only other thing here is that higher moisture content, lower production rate. Again, we just talked about it. It's been raining for 2 days here. Everything's wet.
We're going to try to go
crews
tomorrow.
haven't worked for 2 days. Tomorrow they're going to want to go like a what, and there'll be a tendency. Everybody's stacked up. They want to push the plant, but you can't push the plant because you still got to dry the rock.
Yep.
And so it's actually inverse. So if you try to push the plant too much, we may end up with moisture, and that's not a good thing.
And when you have moisture in the mix, and I told Jim this earlier, is that my guys out in the field would yell, "The mix is tender, the mix is crawling. I can't compact it. We're having trouble."
Right.
And most of the time, it has to deal with the moisture in the aggregate. We're not getting all the moisture out. We have a tender mix. We can't compact it. So what do we do? What do we do when we have a tender mix?
Try to compact it.
We try to compact it more. We beat on it some more.
And then so you're just going to tear it up.
And then the more you beat on it, and then the guy says, "Well, let's put a pneumatic roller on. We can knead it up and heal it up." But guess what we have now? We have a chatter in our mat.
Yeah, the ride is not going to ride very well.
It's not going to ride very well. And I could tell you right now, I could drive across some pavement and feel that chatter, and I know that they had a moisture problem. They didn't get all the moisture out of it. They're fighting air voids. They're fighting density. They're beating on the mat. And that last line there, is it really worth the risk and the cost to run tomorrow? I know everybody's got to meet a schedule, but realize that you're not going to run 400 tons an hour. Again, for every 3 to 7% moisture, we're reducing our production rate by 45%.
I remember talking to one of our members probably a month or so ago, and he's like, "Well, I was asking him because I want to go out to a project." He goes, "Well, I'm not sure if we're going to run or not. Rain last night, and we're going to make the decision this morning whether we run or not." I was like, "Really?" I said, "Yeah, we're going to check our moistures, and if the moisture's too high, we're not going to run." I was like, Well, good on you. Good on you. And
Yeah.
making good, understanding the risk, understanding the cost, making a good decision. So good deal.
Absolutely. So what about additives? So that was the next one on our deal.
Yeah.
We have dry additives here.
Mm-hmm.
And if you look on the left, there's a lime silo or mineral silo that's on the left-hand
Far
side,
left. Yep.
and it's augering into another section that's bringing in the dry additive from the baghouse.
Yep. And that bag house is originally designed to be a big vacuum cleaner to clean out any dust that's going through the process that's caught up in the airstream. But we reintroduced that material. We can bring that material back into the plant and use that material. It's valuable material.
Oh, yeah.
Most of it's dust or very fine fines. A lot of people think dust is minus 200, but baghouse fines are maybe that and a little bit bigger than that, depending on how the plant's set up and how much air they're pulling through the plant. But that material is we think is about a third of the total dust content.
Yeah.
But if your dust content varies just a little bit, it can make a big change on your volumetric. So getting that stuff metered back through properly. We talk about plant operation, about again running the consistency. That plant ought to be running consistent. If it's running consistency, it's going to generate a consistent volume and
material.
also type of fines.
Yep.
And so then when we put that material back into the plant, we're going to have a really good chance of getting a really good mix out of the operation.
We had 7 cold feeds originally, and then we had two
wrap
or
recycle
feeds. So 9. And where's our 10th one at, Jim?
Then we got the mineral filler silo in the baghouse. Now it's 10 and 11. So we got a pile of inputs here.
Yeah. So everybody's got to remember, this is again basic. Mm-hmm. You got to remember that the baghouse is actually it's actually feeding the material into it. I mean, it's actually one of your feeds.
Yep.
And we have to be aware of that. So when we start having issues with fines, or we're starting to have issues with AC, and we start having this fluctuation, go to the basics. Make sure that we're metering in correctly what we're supposed to be metering in, and that we have consistency.
Right.
What else will we have with the baghouse when it's really, really wet outside? Is that we might get caking happening on the baghouse. We might not be getting all the fines back into the asphalt plant.
Yep, if we're pushing too hard.
Yep. On the right-hand side, we have a fiber machine. This is another input that we have.
12.
12.
Yeah.
So if you think about this now, fibers
we're not done yet.
Yeah, we're not done yet. So that's a quite a few moving parts. But again, if you go back to the basics, your loader operator's doing the basic thing right, and we're metering in right, and we're looking at things right, we're gonna have a good material. But the fibers are not in all mixes.
No, SMAs,
PFCs,
thin bonded.
Yep.
And what they do is they help hold additional binder into the mix to help make the mix last longer. We're not using it for any strength parameters. It's basically just trying to hold a thicker film of asphalt around the aggregate and in the mixture itself. So a valuable tool. I like fibers. A lot of people don't like them. They can be a pain if they get wet and that kind of stuff, but they certainly do a good job.
Yeah. So now we have liquid additives. Okay. So we had our dry additives.
12. Now we're okay. Keep going.
So a lot of people are using chemical warm mix. We got a chemical warm mix as a liquid additive, and again, that's got to be metered in correctly.
Right.
And then on the right-hand side, what are those 3 big old tanks we have there, Jim?
Those are our liquid asphalt storage tanks.
Yeah. So that's an additive, guys. That's an additive, and a lot of the times we don't pay enough attention to all the things going into the asphalt plant or going into the asphalt. And the liquid additives, the AC is very, very important. We got to maintain our consistent temperature in those tanks. We need to maintain consistent temperature through our whole system, so that we get the right viscosity, we get the right flow, and then our metering system is correct. All that's got to go hand in hand.
And even though it's number 13, that is our lucky number, because we really need to rely on that binder. And those vertical tanks actually have an impeller or a propeller in there to actually help mix and turn that material and keep it moving. And they're heated, and each one would hold a different product, unless the contractor's running a lot of material and he needs to double up on a plant. So we want to make sure we're using the right material. We didn't show it in this because we just don't have time today, but Generally, we're going to be pulling liquid samples
Absolutely.
during production to test and make sure that they meet all the properties. So if you're an inspector at the plant, you might be looking at that, and there'll be a sample port or a sample device in there to actually make sure we get those samples out and then get them taken care of, get them off to get tested. So, all right, so we're moving on.
Yeah, we got 13
inputs.
13 inputs are all going into a mixing unit.
Yep.
And Jim, I like this mixing unit that you have set up here.
It's a good graphic.
Yeah, you got the aggregate, like you said, coming in from the left-hand side and flowing through. We have our flights that are there to create a veil, and that's to help that material become dry. It's helped the moisture become dry.
Those are shaped specifically to lift the material up and drop it down across the face or the diameter of the drum into that airstream. So you got aggregate coming in this way, and your gas stream or your dryer or your your hair dryer is blowing back the other way. So you have a counter flow drum, which is the most popular type drum out there. And this is one manufacturer's version. There's other versions that have the mixing drum is on the outside.
Got the double drums.
You're drying the aggregate at the beginning. You're heating it up through the middle. And then once it hits where that flame is in the middle, those flights are different. Will actually hold the aggregate to the side of the drum to allow it to pass through and still get conductive heat transfer to continue to warm it up. And then right about here is where your recycle would come in on this drum behind the flame.
Yep.
And then you get into your mixing drum back here. And so what's added here in the mixing area?
So all the additives. So we got all our additives getting in that mixing zone. And
we got our mineral filler, our baghouse fines, our binder, anything else, the
our
fiber,
warm mix.
All that stuff would be coming in right in this area. And then once it gets to the end, it's hot mix.
It's hot mix.
Yeah, there we go.
So that dwell time can vary depending on how long that drum is. And it also can vary with the flight. So you can change those flights up to do different types of mixes. High wrap mixes are going to require different flighting than you will with low wrap mixes, and it's real important to know. Again, it's something that goes back to basics, is that you need to be flighted correctly for where you're working at, your zone that you're working in, and what we're trying to accomplish.
But in general, contractors aren't swapping flights every week. For their particular mixes that they're going to run in a particular area, they're going to optimize their plant. They're going to set it up a certain way. May take them a couple tries, but then they will settle in on a certain drum configuration, and that's going to have to work for the different products that they're going to make in those areas.
That's correct.
But they're fascinating devices.
Really, if anybody hasn't been out to an asphalt plant, this is definitely something that you go out there and take a look at. And now that we're giving you the basics on what to look for, our aggregates and our blends coming in, that's the mixing area. After it gets mixed, it goes through a slack conveyor on the left-hand side. You can see that it's not a great picture, but it's a pretty good picture of a slack conveyor going up to a couple of silos at the top of
right where that material comes out of the drum and starts up its conveyor up that moving sidewalk, if you will, up to the silo. That's where you'll see temperature probes where they're measuring the discharge temperature of the mix, and that's where it's coming. And that if you're in the control house and you see the mix temperature, that's where that material is measured right there. So it goes up to the top. Does it just fall straight into a silo?
Oh, absolutely not. So it goes up a slack conveyor, like Jim said, and then when it gets up there to the top, we have a transverse conveyor, and that transverse conveyor determines where that material, what drum that material is going to go into, right? So it's going to move that material from one drum or the other, and from that area, it drops into a batcher. Okay, a batcher is the next thing it drops into, and these batchers are anywhere between 2 and 4 tons. And what happens with the batcher is that it holds that material to where it just doesn't trickle into that drum.
So it's going to collect.
It's going to collect that
like a
material.
big bushel basket. It's going to collect a certain amount of material and then dump it all at once into the silo.
After 2 to 4 tons, depending on the size of the batcher and your batching, it's going to dump it into the silo in a one full unit to where you're just not dribbling in.
Right.
And the reason we do that is because of
segregation. Yep.
So it's
Yeah,
real important.
If that stuff just trickled in, you'd have real coarse on one side and real fine on the other. And if that batcher is operating properly, it's going to open up and that material is going to fall down and just kind of splat all across and make a nice layer. And so we're building that silo in consistent layers. So again, we're throwing, I think we're up to 22 now on the consistency word, but we still got a little ways to go. But
so I wanted to say real quick here on the left-hand side here, we have the silos, okay? And you see that little tank in between the legs, that little tank that's in between the legs there?
Yeah.
That little tank holds oil, and it holds a mineral oil. And what happens with some of these silos are able to seal the silo off, and then they pump oil into that reservoir, or from that reservoir into the bottom part of the silo or into the top part of the silo. And what it does is it helps seal off the oxidization of the material. When you're not loading, or if you're going to hold it overnight, or if you get trapped with some material. And so those little tanks right there are there to be able to hold that mineral oil for that. Now, I think we'll see that here in a couple of slides from now. But I think it's pretty cool. I think it's somebody really thought this through. How can we make this silo or the storage? And that's why we call it management, because you got to manage your material.
Yeah, we don't want to do any harm to the material once we've made it. We want to keep it consistent when it's discharged from the drum all the way up into the silo, store it properly, store it consistently, drop it into the truck consistently. And then we'll talk about paving another day, but this is a kind of a key element here is this silo management. And the whole science and art of silo management and trying to feed multiple crews with different mixes when everybody wants mix at the same time can be a real challenge. That's why you'll see an asphalt plant start up really early in the morning to fill up their silos so they can at 7 and 8 o'clock when everybody's lining up at the gate ready to go, they can load out as quickly as they can, and they'll continually make mix then. Depending on what they're doing that day, to kind of that serves as kind of a buffer, a surge, if you will,
of material,
a surge, if you will, and then allows them to kind of keep up and get caught back up again.
I love this little picture here, and what I was trying to show here with this picture is that all these silos are insulated. And good silo, good insulated silo, you're only talking about being 100 degrees on the outside, 92 degrees on the outside.
300-degree product on the inside. That's pretty good insulation.
That's pretty good insulation. And the main thing here is that that's what they're designed for. They're designed to store your material so that you can manage your production, manage your life out in the field. Like Jen said, you could jug these silos up early in the morning and then be able to make mix and load out mix different times and be able to be successful out in the field.
Yeah, that infrared gun that you got really are very helpful around an asphalt plant when you're troubleshooting and looking at different things. You can see the consistency from silo to silo to silo there. That uniform color, and then you can also see the hotter material coming up the slat conveyor.
Yeah, I like that.
Going to the top and then coming. It'll be then discharged in. So. Those infrared guns really valuable at an asphalt plant.
Absolutely. One of the things that our guys had did is use that infrared gun and shoot the bearings. Shoot all your bearings, and you can see a bearing going up pretty quick with that gun. It's really pretty. Every asphalt plant should have one, to tell you the truth. Your ground guy should have one.
You don't want to be fixing a bearing at 8 o'clock in the morning when you're trying to make asphalt. So
absolutely.
They cry before they die, generally. There we go. All right.
So loading. So Jim, this is actually a video. I don't know if you could play the video or not.
Play the video.
So if you would play the video, and I just wanted to show everybody that this is again, you got the tanks in between the legs there, and as the video, whoops. Dang, that was the best part of this whole presentation. Down to the left-hand side, it didn't pop up to where you can play the video. Wow.
Oh man,
must be Jenna's fault.
Tune in next time.
Must be Jenna's fault.
We're gonna blame Jenna on that.
All right, so I'm just gonna explain this like the video's going on. So it's a clamshell drop that happens from the silo, and what that clamshell does is it opens up, and the materials is falling, pretty good rate of speed, And
yeah, generally about a ton a second.
yeah,
It's
and
going to
what
come out and they're going to fill up and they're going to fill up and make the first drop in the
that's
truck.
correct. And
And
then
what's the truck going to do?
that truck's going to move forward.
Right. And then we're going to load another drop.
Yep.
A lot of times at the back.
Yep.
And against the tailgate. So we've got consistent material all the way through the truck.
And why do we do multiple drops?
We want to minimize segregation, and I think I'm almost up to the 30. Is we want to improve consistency.
Consistency.
Yeah,
So
absolutely.
Again, when I start going out into the field, or my guys are complaining out in the field that we have segregation, or we have temperature issues, I'm going back and looking at at the bare basics.
Mm-hmm.
Are we doing a minimum of 2 drops?
Yep.
Most of the time in those trailers, we're doing 3.
Yeah, I like to see.
But
3.
are we doing a minimum of 2 drops in these quad axles, or these centipedes that they call them now?
Yep.
Are my guys paying attention to that? And you can see there that he actually has a tarp system.
Mm-hmm.
Do I have a good tarp on it, or do I have a mosquito net tarp? And again, if it's 300 degrees and it's 100 degrees outside, and I'm in Laredo, Texas, maybe I don't need to have that all-weather canvas tarp. But if I'm fighting temperature issues, I'm fighting density,
and I'm hauling 100 miles,
and I'm hauling in 100 miles,
and the wind's blowing,
you got to take a look at the tarps. You got to take a look at what's going on.
Big fan of tarps.
And again, it all boils down to consistency. If my guy out in the field cannot consistently achieve his density, I've got to look at why. And so I'm going to go backwards, right? And I'm going to go backwards. I'm going to go to the asphalt plant. If I have segregation issues, I'm going to go back to the asphalt plant. Maybe my gob hopper's not opening correctly. Maybe my loader operator is not paying attention and he loaded the wrong coal feed, or it's contaminated, or we're having issues with material coming in. A lot of these asphalt plants have a little footprint. In other words, they can't store thousands and thousands of tons of material. They're bringing material in as we're sending material out. So you got to have a QC guy there all the time doing what? Running moisture,
checking moisture, so they can make
specific gravities,
small adjustments in the plant as they know. And a good loader operator is going to be working with QC, so they know where the pile is, and if they need to make an adjustment on the 78 stone or the D rock or whatever, they can make that change as they're moving through the pile, and so they stay in bonus, and they got consistent product going out the front gate. So absolutely.
And what's the main tool that we have available to us? It's a simple tool. It's a control chart. That's the main tool. It's simple. We're running these gradations. We're running these moistures. Plot them. Put them on a control chart. You guys have seen the fundamentals. We've had the fundamentals going back and forth on the fundamentals.
Yep.
The very fundamental aspect of a control chart in an asphalt plant is muy importante. We got to have those control charts, because again, you can look at a control chart and within seconds see I'm going to have trouble.
Right.
Before
you're looking for trends.
Before my QA gets there, before my sample gets there, I'm a good 1A guy and I know what's going on. I can tell you if we're going to have trouble. And so Miles Garrison, he's a believer in control charts. So am I. Miles has said it 100 times. If you have any kind of issue whatsoever, look at that control chart, and you're going to be able to identify the problem fairly quick and be able to get it before it becomes, systemic.
Yeah, really hard to look for trends by only looking at single test results. But as soon as you start charting them out, boy howdy, it just flashes up there quicker than I don't. And ideally, what we want to be able to do is we want to identify the trend.
That's right.
And we want to change that trend before it reaches the limits, or before we get out of spec, or before we start losing our bonus. We want to keep that on the straight and narrow, whether it's an 8 sieve, an asphalt content, or the density, or the core density coming in from the field. We want to keep all those on the straight and level to make sure we're getting a good product. And so, absolutely.
And again, if you have to put it in a chart, you have to see it on a chart. If you're just looking at the numbers, you won't see the trend that Jim's talking about.
All right, so let's wrap it up.
All right, I think that's about it.
Yep.
That's what we had. We hit the 7 top functions there: the blending, the heating, the drying, the additives, the mixing, the storage, and the loading. My favorite one would be loading, that we didn't get to hit, but hey,
I'm sorry.
Yeah, it's Jenna's fault. Jenna's probably the one to blame for
She's
that
like,
one.
that wasn't me. I had nothing to do with the PowerPoint. So, hey,
But
good job, Chuck.
hey, that's basics. And again, go to the basics. You don't have to reinvent anything, or you don't have to be a PhD or geologist. You don't have to. You can go back there and look behind the asphalt plant. If that loader operator is running uniformly, he's loading from the front of the stockpile. You're bringing in material to the back. They're sloped. You know that they're consistent. That loader operator is not overfilling the bins. We don't have cross contaminations with that. You're going to have a better shot at getting a bonus on your production than any other time. And again, a 1A, his responsibility is not just to sit in that lab, it's to go out there behind that asphalt plant and look at those stockpiles, look at that wrap stockpile, take gradations of that wrap stock, take AC contents of that wrap stockpile. But that 1A at the asphalt plant, you 1As at the asphalt plant, you got more responsibilities than just sitting in there. You need to be behind the asphalt plant and really taking a look at it.
Good deal. Chuck, thank you so much for playing today with me here. Be safe out there. God bless. Remember, it's still Work Zone Safety Week, and every day ought to be a safe day. So God bless. Take care. We'll see you next time on TXAPA Live.